Welcome to our video presentation exploring volumetric analysis and its significance in the world of winemaking. Before we begin, here are our team members, including ALISA AZARIN, ANGELO ADRIANO, IVELINE Richard, Muhammad AIMAN ARIEF, and me, NURUL AZIRATUL AINAH. Volumetric analysis is a precise method used in chemistry to measure the concentration of a solution by analyzing volumes. It's like the detective work of chemistry, helping us uncover important details. Now, titration is the key part of this. It's where we take a solution of non-concentration, the titrant, and we mix it in the solution we want to analyze, the analyte. Be carefully measuring how much titrant is needed to react completely with the analyte. We can determine its concentration. The process involves using precise instruments like burettes and flasks. It's all about accuracy and making sure every drop counts in our analysis. In the wine industry, titration is incredibly important. It helps winemaker measure acidity levels, especially the amount of tetratic acid in their wines. This acidity is crucial. It affects the taste, stability, and aging potential of the wine.
As a theory, volumetric analysis has its own principles which needs to be followed. If these basic principles are not followed, then the final result might be different. Researchers study these things by looking at the principle of the chemical that they are using. Every industry must have these instruments must be there to do the process correctly. Other than this, they are highly used in various industries around the world, including wine. To come up with a new product or innovation, this analysis become quite important for many industries. Winemaking begins with an ordinary fruit such as grape and end with a solution of various acids, esters, salts, small molecules, and ethyl alcohol. Modern technology like analytical instrument has greatly improved the quality and consistency. High-end procedures also showcase the uniqueness of their grapes blend, growing conditions, and how grapes are processed. Vintners now focus on diagnostic characteristics like tetrable acidity, volatile acidity, and free for total sulfur dioxide, which can be accessed through titration.
Methodology: tartaric acid used in winemaking that is essential for controlling the acidity of wine, helping to maintain its taste and preventing microbial growth. Based on the equation above, we are going to titrate the strong acid, sodium hydroxide, with the weak acid, tartaric acid. Produce sodium, titrate, and water. Fill up the burette with sodium hydroxide up until calibration mark. In this experiment, we use 0.1 molar concentration of sodium hydroxide. For safety precaution, use glove while handling sodium hydroxide and work in well-ventilated area to avoid inhaling fumes. Second, use pipette filler to pipette tartaric acid and transfer it into the conical flask. Next, add 2 to 3 drops of phenolphthalein indicator into the conical flask. Titrate the tartaric acid with the sodium hydroxide from the burette. Open the tap to allow the flow of sodium hydroxide to run out while shaking the conical flask slowly. Shake the conical flask until a slight pink color can be seen in the conical flask. This indicates that the endpoint has been reached. Record the final volume of sodium hydroxide in the burette. Repeat this experiment to get more accurate result.
So this is our result for this experiment. In this experiment, we already know 2 mol of sodium hydroxide is 0.1 mol. The first step is by calculating the average of volume titration. And to do that, we have to take our constant value. We have 19.5 plus 18.5 plus 18.7 plus 18.6 divided by 4. The total of the titration volume is 18.83 sodium hydroxide. Now, we can find the number of mole of sodium hydroxide by multiply the concentration and volume. So our concentration is 1.9 exponent negative 3. Next, by doing so, we can calculate law of mole of tartaric acid. With the equation half the number of mole of sodium hydroxide, we will obtain 9.5 exponent negative 4. From there, we can calculate the final concentration. In this experiment, the volume of tartaric acid that we use is 20 ml. So we can calculate the concentration of tartaric acid, which is N of mole of tartaric acid over volume of tartaric acid, and give us a value 0.0475 mole over liter. Next, we need to convert mole over liter to gram over liter because the total acidity of wine is usually in gram over liter. Then, we take our concentration, which is 0.0475 mole times with molar mass of tartaric acid, which is 150.087 gram over mole. So, our final answer is 7.129 gram over liter. Lastly, to determine the percentage of tartaric acid by weight over volume. First, calculate the mass of tartaric acid in grams per liter, which was found to be 7.129 gram over liter. Then, to find the percentage, divide this mass by the total volume of the solutions and multiply by 100 to express it as a percentage. Therefore, the percentage of tartaric acid by weight over volume is calculated using the formula mass solute over volume solvent times 100%. In this case, the mass of 7.129 grams of tartaric acid dissolved in 1000 liters of wine indicates that the wine contains 0.71% tartaric acid.
In conclusion, volumetric is a method used to determine the concentration of a sample. For instance, in the video we use wine as our main sample. We can determine the concentration through titration by measuring the endpoint, which can be obtained through detecting the color changes upon neutralization. Then, we can relate the concentration of the base and acid. The result can be achieved once the solution turns into light pink.